Hi everybody, I'm here with Miguel Bojórquez, Arturo Clemente, and me, Luis Gallardo, and we're going to present about our case study of operational research, which is fabrics in fall fashion. Now, given a little bit of the company's background and what we're going to talk about, we're going to talk about the trend lines. What are trend lines? Well, the trend lines is a fashion company in which they design and produce clothes for the fashion industry. In this case study, we're going to focus on Catherine Rowley, and because she's the owner and manager of Trendlines, which is something we're going to be talking about. A little bit of background of the company. Well, Trendlines is right now in a dilemma, and they need to produce the next plan for the fall line. In this case study, we can see and appreciate Catherine Rowley being in this predicament. More background of the company. Catherine must determine the quantity of each clothing item she should produce given the plant's production capacity, limited resources, and demand forecast, which are some of the constraints. Now for the cost, Catherine studies the clothing patterns and material requirements. Her fall line consists of both professional and casual fashions, so there's two types of fashion she's going to be focusing on. She determined the prices for each clothing, fashion and casual, by taking into account the quality and the cost of material, the cost of labor and machining, the demand for the item, and the prestige of the Trendlines brand name. All these elements are something that she focused on to consider the price. For the explaining of the cost. Now for the clothing item, which is tailored wool slacks, the material requirement for this, it's 3 yards of wool, 2 yards of acetate for lining, and they have a price of $300 with a labor and machine cost of $160. Next one is the cashmere sweater, 1.5 yards of cashmere with a price of $450 and a labor and machine cost of $150. And silk blouse, 1.5 yards of silk, $180 for the price of the material, and the labor and machine cost for this one, for the clothing item, is $100. Next, the silk camisole, it's 0.5 yards of silk with the price of $120 and a price of $60 for the labor and machine cost. Next is the tailored skirt, which requires 2 yards of rayon, which they have a price of $270 and $120 for the labor and machine cost. And last but not least, the wool blazer, which requires a 1.5 yards of acetate for lining, 2.5 yards of wool, and 1.5 yards of acetate for lining, with a price on the material of $220 and a labor and machine cost of $140. Next are the velvet pants, which require 2 yards of velvet and 2 yards of acetate for lining, a price of $350 and $175 on the labor and machine cost price. Next is the cotton sweater, which requires 1.5 yards of cotton, $103 is the price of it, and it has a $60 of cost for the labor and machine cost. Now for the cotton miniskirt, it's 0.5 yards of cotton required, with a price of $75 and a labor and machine cost price of $40. For the velvet shirt, is 1.5 yards of velvet, the price of $200 and a labor and machine cost of $160. For the button-down blouse, is 1.5 yards of rayon as a material requirement, $120 of price, and $90 for labor and machine cost. Next is the prices for all the materials, which are as follows. For the wool, it's $9 price per yard. The acetate has a price of $1.5 per yard. The cashmere is $60 per yard. The silk of $13 per yard. The rayon of $2.25 per yard. The velvet of $12 per yard, and the cotton of $2.5. Cashmere being the more expensive.
So then we move on into the linear program modeling variables. Here we can see all the variables, which are tailored wool slacks, cashmere sweaters, silk blouse, silk camisoles, tailored skirts, wool blazers, velvet pants, cotton sweaters, the cotton miniskirt, the velvet shirt, and the button-down blouse. Here we have them labeled up from X1 all the way to X11, and 0 if are available. So right here we move on into the the linear programming. In each one, we can see in this table the profit of each one. We see the wool slacks, a profit having of 110, the cashmere sweater having a profit of 210, the silk blouse having a profit of 60.5, and the silk camisole having a price of 53.5. Tailor skirt having a price of 143.25, the wool blazer having a price of 155.25, the velvet pants a price of 136, the cotton sweater having a price of 66.25, the cotton miniskirt a price of 33.75, the velvet shirt a price of $22, and the button down blouse a price of 26.625, which is 63. So we move on to the LP model in our objective functions. Here we have our fixed costs, which are the designers, the 3 fashion shows, which are fall, spring, and summer, and our total fixed costs. The team designers is a price of $860,000. The 3 fashion shows have a price of $8,100,000, and our total fixed cost is $8,960,000. And our objective function is we're trying to maximize, and there we can see our what we're trying to do. And yes, we can all see the LP model right there. So then we move on to the constraints. We can see that the wool we have an available of 45,000. With the clothing item that requires the material is 3 tailor wool slacks with 2.5 wool blazers. Then we move on to the acetate, which is 28,000 with 2 tailor wool slacks with 1.5 tailor skirt, 1.5 wool blazer, and 2 velvet pants. The cashmere have a 9,000 available, and the clothing item that requires material is 1.5 cashmere sweaters. The silk having 18,000 available, and 1.5 silk blouse and 0.5 silk camisole. The rayon having a 30,000 available, and a 2 tailor skirt, 1.5 button down blouse. The velvet 20,000 available, and 3 velvet pants, 1.5 velvet skirt, and a cotton at 30,000 and 1.5 cotton sweaters with 0.5 cotton miniskirts, having the item that requires material. We want to more constraints, which is our products, which is the tailor wool slack, which you have a max amount of 7,000. The cashmere sweater, which you have a max amount of 4,000. We have the silk blouse with 12,000. We have the silk camisole with 15,000. We have the wool blazer with 5,000. The velvet pants with 5,500, and the velvet shirt 6,000 max amount. And then we move on into another constraints, which are the tailor wool slacks with a minimum amount of 4,200. We have the tailor skirt with 2,800 and the wool blazer of 3,000. Then we move on from products from scrap, which are the silk blouses, which reduces scrap to silk camisole, and a cotton miniskirt to cotton sweater.
So first we have the question A. That is now trying to convince Scattering not to produce any velvet shirts since the demand for this fashion fad is quite low. He argues that this fashion fad alone accounts for 500,000 of the fixed design and the other cost. The net contribution, which is the price of the clothing item, materials cost, labor cost, from selling the fashion fad should cover this fixed cost. Each velvet shirt generates a net contribution of $22. So he argues that given the net contribution, even satisfying the maximum demand will not yield a profit. So the question asks, what do we think of Tech's argument? And we believe that it is incorrect because the fixed design and the fashion costs are sunk and should not be considered in July. The velvet shirts contributing to lost sales should be produced according to the linear programming model. If Tech has raised these concerns before incurring the fixed cost, his idea might be feasible, but since he did not, the argument fails. Now we move on to the question B, which says to formulate and solve a linear programming model, maximizing the profit given production, resource, and the main constraints. So as we have seen by our classmates, we can see that we first, to make the camps, we declare the variables, which will be the products that we're doing, from the velvet shirt, the tailor wool shirts, and all that. But we also have to declare our variable C as it being free, because it may move from positive to negative. We cannot control that. So next, we want to declare the equations that we're going to be building, which is the objective, and the equation for each one of them, the wool, the acetate, the materials. Then we have the other set of equations, which is the max, from how much we can produce given the the demand that is required from trend lines. Then we have the minimum, the amount, the products we have to make. And also we can see the scrap that it will be greater. The product that's being done from the scrap than the product itself. It has to be greater. First, we have our objective function that goes involving the profit of each one of them. So as we can see, it has a product of 110 for the first product, 210 for the second product, so on and so forth. Next, we have the constraints given by how much material they require, and also how the maximum amount we can get from the wool. We had like 45,000 yards. So we require a discrete amount of yards for each one of them. So that is declared there. We also have that we have a maximum amount of products. So now this is considering the amount of products that we're making, not from the material. That and also with the minimum and the scrap sale. Next, we declare the model that we're going to be doing, which is the profit. We tell it to maximize C, and we also tell it to display the variables that we're seeing. And then in the right, we can see that we had 402,200 for the tailored shirt. We had 4,000 for the cashmere sweater, and so on and so forth. However, we can see that we do not need to produce any product for the variable x7 and x8, which is a problem if it were declared, but since we did not declare that it was needed for them to have a product, it is what it is. And the optimal solution found is that the profit will be of negative $2,097,066.6. Now the question C informs that the textile wholesaler informs Catering that the velvet cannot be sent back because the demand forecast show that the demand for the velvet will decrease in the future. Catering can therefore now get no refund for the velvet. How does this fact change the production plan? So as we can see from every constraint here, we had it set from greater than. This is because we can refund them, but in this case we cannot do it for the velvet, so we change the value from greater than to equals. And as we said right here, since you cannot do a refund, we put an equal sign. This will change. What this says is that we now need to produce the variable x7, which I said there was not going to be produced in the optimal profits solution. That is what changes. We had to produce less tailored shirts to produce more velvet pants, and officially we cannot return the velvets to the customer, and thus it becomes to a sunk cost. Now for question E, the sewing staff encounters difficulty sewing the arms and the lining into wool blazers since the pattern has an upward shape and the heavy wool material is difficult to cut and sew. The increased labor time to sew a wool blazer increases the labor and machine cost for each blazer by $80. Given this new cost, how many of each clothing item should trend lines produce to maximize profit? So in the table that my partner Arturo Clemente talked about, we saw the labor machine cost reducing from the price of each product, and now this will be the new profit that we have for the wool blazers, and this changes how we can sell the item and overall reduces even more the profit that we had. Now in question F, we have that the textile wholesaler informs Catering that since another textile customer canceled his order, she can obtain an extra 10,000 yards of acetate. How many of each clothing item should trend lines now produce to maximize profit? So here we have that the value of 28,000 previously is now changed to 3,800. We compute the GAMSA again, and as we can see, it is better to produce the first items that are now selling for more. and our objective function, the objective solution, my bad, went from negative 2 million to now much better, $1,378,733. And yes, thank you. This is the end of our presentation. I think this was a very good project to see because it allowed us to find a problem that is going to be encountered most likely in a real case. It can be for many companies, not only fashion and textiles, but also we can put it to engineering. We can put it to Maquila here in Mexicali. We could put it as in the hospitals that also deal with clients, they deal with times, and we could also put it with airplanes, that how we need to produce and optimize the amount of time that is going to be done. And yeah, I found it very, very helpful. If anyone has any other opinion?
Yes, as my colleague said, I find this project very informative, because as we live in right now in today's world, in today's society, we have a lot of people working into fashion, in the fashion industry, and this is something that gave us a little bit glimpse of what is going on inside their world, and it actually helps us, as my colleague said, helps us implement this into our not our daily lives, but maybe in the field of work we want to partake in. So I feel like this project was very informative and very eye-opening.
Yes, I totally agree with it. I mean, like my teammates has already mentioned, this project helps a lot to future engineers because it already like puts you in a perspective of what fieldwork could be, something that you could be dealing anytime on your field work, as well as how to develop it and how to work with it. So this is very helpful and informative for any future engineer. So trying and being able to work in this project is going to be really helpful in the future.
Thanks for your attention.
Thank you.
Thank you.